Alright, what's going on, guys? In this video we will be going over generator. So what are generators? If you see the word yield in a function, so in this function here, as you can see the word yield, you're seeing basically a generator. These are special types of functions, in this case a generator function, that create an iterator object for us. So when calling next on these iterator objects, it essentially starts the function and then it cycles one yield iteration at a time. So I know this sounds a little strange, but I'm going to show you an example. So we have this function counter, and what's going to happen is when we call this function, we're going to create a generator object, x. So let me just run this, okay. And now we've created a generator object. So if you look at type x, you can see it's a class generator. So to actually run this function, remember this is a generator object. To actually run the function, what you have to do is call next. So in this case, I'm going to type next, and since the name of this function, this object is x, we're going to call x. So what happens here is it starts the function, and then once it gets to the yield statement, it pauses. So in this case, we start the function, so it's going to say print function starting. So we're going to print function starting. It starts this iteration, print going to yield, and then we yield the number 3. So we pause at the yield statement. Whenever we iterate using a generator object, we always pause at the yield statement. The first time we use the method next, it runs the function for the first time. So in this case, we'll print out the function starting. Then for I in range, we start this iteration or this loop, and then we'll print going to yield, which we did, and we'll yield num. In our case, since we assigned 3 to num, that's the number we're going to print. And now we freeze. So with generators, what happens is every time we call next, we sort of go through the loop and then we freeze at yield. So we're always freezing at yield. So calling next again will cause us to iterate once again until the next yield statement. So the next time we call yield, what's going to happen is we're going to run num plus equals 1. We're going to print out this statement, and then we're going to go back to this loop. So for I in range 30, we're going to print going to yield, and then we'll output yield, and we'll pause again here. So with the generator, you sort of iterate until you hit this yield statement, and then you pause at the yield statement. So another iteration, we'll go through this iteration and then pause at the yield statement. We'll keep doing this as long as we keep calling next. And eventually what's going to happen is we're going to exhaust this for I in range 30. The generator object is going to exhaust itself, and if you try to run it one more time after exhausting itself, what happens is you get an error. So I'm going to try hitting next. So when I hit next, the next thing we should see is num plus equals 1. So remember, num plus equals 1, since it's not a print statement, we're not going to see anything. But we should see this print statement first, and then we should see this print statement second, and then we should see the yield. So it should be, now we're going to update number, followed by going to yield, and followed by a num. So let's just run next once again. Yeah. So now we're going to update number, going to yield, and 4. So as you can see, it once again cycles through and pauses at the yield statement. So that's essentially what a generator does. So generators allow us to run the function at the pace we want and getting the output one at a time, essentially at the pace we want. Regular functions, on the other hand, can't do this. Regular functions can only return values one time, and after that, they terminate. I'm just going to copy the function and I'm going to paste it here. So this is an example of a regular function. So let me break this down. It's just a simple I loop, and you're going to print the number and num plus equals 1. So in this case, we either have to print each of the outputs, or the other thing we can do is just return the final value. But we can only do this once. So when we run a regular function, we can only get one output, unlike a generator function, which allows us to get values one at a time, a series of values, as opposed to a one-shot deal. All right, so I'm going to run this now. I have to actually call the function. So let me just call counter function 3. It's the same thing. So let's just run this one more time. And okay, so as you can see, it outputs everything at one time, as opposed to the generator, it's outputting things one at a time. And if you get rid of the print statement, well, in this case, it shouldn't output anything. Yeah, so the only thing we can do is we can return num. So the only thing we can do is return num, and that's also just a one-time value. Counter function can only output values once, as opposed to a generator function, which creates a generator object. It can output values many times. So now the next thing I want to do, let's take a look at an infinite loop. So, alright, so what I mean by an infinite loop is a while true loop. So this is going to be another generator, but I'm going to show you some benefits of utilizing a generator. So this is a simple generator that's utilizing an infinite loop. The iteration doesn't end in this case. So we're going to be continuously yielding something as long as we call next. There's no exhaustion. As opposed to earlier, for I in range 30, after 30 times we exhaust, and the generator function or the generator object will come to an end. So this basically just takes in a number, and we're going to yield that number, and then each time we run the generator, we're going to yield the number squared. Here we have the freedom to run the function as many times as we want, and the num is updated each time with iteration. This is a very simple function, but in this case, say we didn't know how many times we wanted to run this function, and we didn't know which values we wanted to utilize or how many times we wanted to utilize. So in a situation like this, where we need continuous values, but we don't know how many times we're going to have to run this function, these types of function generators are very useful. So I'm just going to run this, and I'll show you. Alright. Call this squares equals, and we'll take the value 3 as the initial num value. Alright, let me just run this. Run cell. Okay, so anytime you want to run a generator object, you always have to call next on it. And this will initialize, not initialize, but it will start the function. Using next for the first time, it's going to start the function, and then we'll get stuck in this while true loop, and we'll continuously iterate. So next square presents a value of 3, which is the initial value that we assigned to num. Now if I run this again, say I was interested in squaring it one more time. So by utilizing x squares, I will be able to take the original value of 3 and then square it and then store the new value. So now we have 9. So 9 gets saved, and if I want to run squares again, if I wanted the square of the new updated value, which is 9, I'll get 81. So now if I run it again, it's going to take the new value, run it again. So it's almost like a recursive function. It updates with the old value, then runs it again. With the recursive function, you have to know beforehand how many times you want to run the function, or all that is sort of hard-coded. It's going to be determined for you by the recursive function itself. But in our case, we sort of control the amount of times we want to use this function. Here, since we're using a while true statement, this function could run indefinitely. So there is no exhaustion with this generator. We don't have to worry about all these values being stored in memory, because nothing's being stored in memory. We could decide which values we want to store and which values we want to throw out. So there's a lot of freedom here using with generators. So now this situation where we take the old value, update it, we could save the old value that we got from the function, and then run the function again on the new update value, then run it again. This sort of freedom is very hard to do with the regular function, because we would have to know beforehand how many times we want to run the function, as functions only return values once. Let me just get a copy of a similar function, but this time it's called a squares function. So this was a squares generator, and this is a squares function. So we're going to actually return a value. So while true returns num times num. Alright, so I'm going to run this, and here we go, 9. Now we can't do anything about this. If we try to run this function again, it's going to produce 9. It can't save the value. All it can do is restart the function and output a value once, and then the function is dead. Alright, so if we had a continuous stream of data that's coming in, or we want to generate a continuous stream of data, and we don't know how much data is coming in, or we don't know how much data we want to generate, we can do so with generators without storing all of it in our memory. So if there's a ton of information or a ton of data coming in, and we don't know how much data, and we don't want to store all this data, what we can do is we can cleverly utilize generators to efficiently cycle through all the data. So we can cycle through actually millions and millions of data units without using much memory. And we also have the option, since we're going through millions and millions of data units, we have the option to select which data we find interesting, and we can actually store that data. So in this case, so I'm going to run this again. If we do next squares, then you can always save something like y equals next squares, and we could save the values that we find interesting. Y equals squares, so y equals 9. So if we update it with the next value, so y is now 81. So generators are very useful for when dealing with large amounts of data, and you don't want to save that data to memory because it would essentially crash your computer. And generators take up very little memory. So generators seem to be used often when dealing with servers, networking, web service, where there's always continuous data. I'm not too familiar with web services and servers and networking, so I haven't really used generators much, but I plan to explore it a little more and see how I could utilize it in some of the stuff I want to do with web scraping and automation and things like that. But the one thing I want you guys to just keep in mind is that in this case we're doing very simple examples, very simple functions that are yielding just integers. With generators we can yield Python objects, complex functions. You can return some very complicated Python objects. You're not confined to these numbers that I'm using in this case, these simple cases. I don't have any real world examples at the moment, but I will put a link in the description which shows many different applications of generators. So this was just a quick introduction to generators. I'm hoping to introduce coroutines. Alright, so that's it for today. I will see you guys next time.